In our last example in this section, we're going to see a trickier substitution problem. We have the indefinite integral of x times the square root of x plus 1 dx. Now, if this were just, say, square root of x, if I didn't have that plus 1, then I could use some properties of exponents. I could rewrite that as x to the 1/2 power. We could simplify it, and we could go ahead and just use our regular old power rule. But because we have this plus 1 right here, we technically, in this problem, have a function x plus 1 inside of another function, the square root function. So this is definitely going to be a substitution problem. So for my inside function, I'm going to look inside of that radical. I'm going to take u is equal to x plus 1. Once you've got u, we can immediately find du. Du is just the derivative of u, so that's the derivative of x plus 1, which in this case, that's just going to be 1 times dx. Or if we wanted to simplify that further, we've got du is equal to dx. So I'm going to think about what we have accounted for and think ahead to what our substitution is going to look like here. We said x plus 1, that's going to be our u. So after we make that substitution, that's going to be the square root of u. We have du is equal to dx here. So I can take out that du and I can take out that dx and replace it with du. So we'll say that part is du. The problem that I'm going to run into in this problem is this piece right here, this extra x. Because right now, as it stands, this is what my problem looks like. I have the antiderivative of x times the square root of u du. And we don't really want to see this happening. We don't want to be mixing and matching our variables. We want something that is entirely in terms of u. We don't ever want to have x and u at the same time because we don't know how to integrate that. We haven't fully made our substitution yet. So we need to find some way to accommodate for that x, to account for that x. So one thing we might try is, what if I took this equation right here? What if I just multiplied both sides by x? On the right-hand side, I could write that as x dx. But then on the left-hand side, I'm actually going to run into the same problem that I had, where here I've got x du, which that's exactly what I have right here, x du. So unfortunately, that's not going to work for us. We can't try that. I'm going to think about where else do we have x on that right-hand side. And I see this piece right here. I see u is equal to x plus 1. Remember that this is an equation. I'm going to actually rewrite this part. I'm just going to say u is equal to x plus 1. Since that's an equation, I should be able to subtract 1 from both sides of my equation. If I do that, on the right-hand side, I'll have x, which is exactly what I want. That's the substitution I'm trying to make. And on the left-hand side, u minus 1, well, that's just u minus 1. So that means where I have that x highlighted, I can actually take out that x and replace it with u minus 1. So our next step of our substitution will have the indefinite integral of u minus 1 times the square root of u du. Now you might look at this and say, well, all right, geez, Mr. Huber, how is that any easier than, what we started with? Why did I do that? It doesn't look any easier. Well, the reason why this is a whole lot nicer is because this is something I can actually simplify. I'm going to do some clever algebra here. I'm going to first of all rewrite this square root of u as u to the 1/2. So we'll have the indefinite integral of u minus 1 times u to the 1/2 power du. And I'm going to take this u to the 1/2 and I'm going to distribute that. I should be able to take that and distribute that. So this is really u to the first power. When I multiply variables, I add their powers, so I should have u to the 1½ power, or u to the 3/2 power, minus 1 times u to the 1/2 power would just be u to the 1/2 power du. This is now something that we can work with, because that we can just use our regular old power rule with. So there I can just go ahead and add 1 to the power and divide by our power. So I'm going to do just that. Adding 1 to the power here, 3/2 plus 1. Adding 1 is the same as adding 2 over 2. So this would be u to the 5/2 power. Instead of dividing by a fraction, I'm going to go ahead and multiply that by the reciprocal. We'll multiply by 2/5. Minus, I'm going to do the same thing for my second term here. Adding 1 would give me u to the 3/2 power. Multiply by the reciprocal, this would be 2/3. And at this point, we have done our power rule, so we want to go ahead and add our constant of integration c. And this is now our antiderivative. We're pretty much ready to go. The very last step we need to do, as usual, is to take this original expression in terms of x, this x plus 1, and plug that back in for our u. So we'll have 2/5 times, instead of u, we'll have x plus 1 to the 5/2 power minus 2/3 times x plus 1 to the 3/2 power plus c. There is our antiderivative. So be on the lookout for problems like this. These are very tricky problems because it's actually kind of a double substitution we're making. We're actually substituting for u within the square root, but then also with that u plus 1. What you'll see when we need to use this method is usually we'll have the same power of x on the inside of our function as we do on the outside of the function. So here in this case, we had x to the first power on the inside of the square root, and then we also had an x to the first power on the outside of the square root. It's not a guarantee that we'll be using this rule, but it's something that we can kind of keep an eye out for on this section.